So in the last video, we discussed about the smart grid layered architecture. We saw the various layers in the smart grid architecture. We started with component layer, then we discussed the communication layer, then information layer, then we discussed the functional layer, and then we discussed the business layer. Now let's discuss all those layers which we discussed in the architecture one by one and see the details which are there in the individual layers. So in this video we will especially talk about the smart grid communication layer. So in the field you will see that the smart grid communication layer is composed of multiple technologies, because depending upon the area in which the communication requirement arises, the communication technology is chosen accordingly. Say for example, for house, we develop the home area network, which will interact with the EV charging station or electric vehicle. It will also interact with the home controller and the integrated home display. It will also interact with the various appliances which are there in the house, and it will also interact with the various meters. So meters can be energy meter or gas meter or water meters. So what will happen that for house to acquire the data, we need the home area network to be set up, through which we will acquire the information from various devices which are connected in the house. So house level network, that is house area network, is mostly a Wi-Fi network in the house. We also have other technologies like Zigbee for the data acquisition at the house level. After the data is being acquired at the house level, the data from various houses can be collected using Zigbee or maybe RF mesh. Similar kind of technologies we can utilize, and then we will have data concentrating unit which will acquire data from nearby houses, and through repeaters it will send data to the control center. So this is how the data at the house level is being shared to the control center. We will discuss all of these things in detail when we will talk about the advanced metering infrastructure and smart meter in detail. Now this is the solution which we generally see when we share the smart meter data with the control center. Then there are substations also, where we have various substation devices connected, say remote terminal unit or maybe intelligent electronic devices which are part of our substation architecture. They will interact with the control center using various communication mechanisms. One of them is like optical fiber network, which we can utilize to share the data over a long distance, or we can utilize the wireless network also to share the data to the control center. One of such example is the MPLS, that is multi-protocol level switching. That is again similar to the GPRS network, where the MPLS protocol is being utilized to give the priority for the data packet to travel from substation to the control center. So various possibilities are there to create the wide area network or the neighborhood area network for sending the data from substation to the control center. Now the data can be shared with the help of optical fiber or maybe wireless using GPRS 3G or maybe the Wi-Fi if the substation is nearer to the control center. So different technologies have different limitations. So when we will discuss the communication technologies in detail, we will discuss how the various communication technologies can be utilized in various functional applications at the power system network. Other possibilities are like the houses can be directly connected to the optical fiber, or we can use PLC, that is power line communication, for sharing the data. So communication layer contains multiple possibilities of sharing the data. It depends upon what kind of technology we are utilizing at which level. Let's see what are the various possible technologies which we can utilize at various layers. Say for example, at house level, where we develop the house area network, the major requirement is to exchange the information among various devices installed in the house itself, say home appliances or the controller of the house or the smart meter and so on. So the smart home gateway will share the data from house to the external world. Mainly the smart meter data is communicated to the external world, where we are exchanging the information related to energy consumed by a house. So at the house area level, where the customer domain of the NIST domain is touched, the possible technologies are ZigBee, Wi-Fi, Longworks, BSENet, HomePlug, or OpenHAN. So these are the possible technologies which are available in the communication domain. So we need not to worry about those technologies at this point of time. Couple of technologies which are required we will discuss when we will go through the various communication technologies. So we will discuss important technologies which are the building blocks of the smart grid architecture. So for example, ZigBee and Wi-Fi are the two basic technologies which are widely used at the home level for data exchange. The HAN, that is home area network, is the last mile network where the field data is being acquired. From there the data travels to neighborhood area network, means the smart meter data from all the houses is being aggregated. So at the edge of the neighborhood area network you will see the data concentrator unit called as DCU, which is responsible to aggregate the smart meter data from all the houses, or maybe the controller information from all the houses, aggregate it at the neighborhood area network, and then push the data to the upper layer, that is wide area network. The neighborhood area network is mostly being utilized at the distribution system level, where the example members are like relays, modems, bridges, or different access points are being utilized to share the data at the neighborhood area network level. So what are the possible technologies here? We have WiMAX, broadband over power line or power line carrier communication, wireless mesh, IEC62056. This we will discuss in detail when we will talk about the smart meter data communication. IEC62056 is also called as TLMS COSHAM protocol for the smart meter data communication. So out of the technologies which are listed here, we will discuss mainly about the IEC62056 and the power line carrier communication. The power line carrier communication is very important to understand. It is a old technology for sharing the data between various substations, but it is also being increasingly utilized at the house level to share the data. So when we'll discuss the communication technology, we'll discuss them in detail. Now, after the data concentrator unit, the data travels to the control center. At control center, we will have metadata management system to accept the metadata. For other information collection, we will have SCADA system also at this level, where the substation related data will be collected. We may also have other applications also, like phasor data concentrators, where the PMU data is collected. So this is the boundary line of the control center, where the devices will collect the data from the field for running the various applications at the control center level. So for sending data from neighborhood area network to the control center, we utilize wide area network. Now the wide area network is mainly interacting with the transmission layer or the data which is traveling over a long distance. Here the possible technologies are SONET, that is synchronous network, WDM, wave division multiplexing, ATM, that is asynchronous transfer mode, MPLS, multi-protocol level switching, frame relay, satellite or microwave, IEC 61850 and DNP3. So IEC 61850 and DNP3 are the two major protocols which we will discuss. These are the protocols which are used at the transmission level. 61850 is mainly used for substation automation, where the intelligent electronic devices interact with the enterprise applications using 61850. Now the DNP3 is the SCADA communication protocol. We will discuss these protocols when we will talk about the various power system protocols later in this course. Now the enterprise level, we will have mainly the enterprise related operations and the operations related to bulk generation. So here all the software applications will be utilized for better monitoring and control of the system. The example applications are metadata management system, customer information system or billing, outage management system, workforce management system, energy management system, distribution management system, and these SCADA applications. So all these applications are part of the enterprise layer of the communication. Here we utilize mostly IEC 61970, 61968 protocols. We will discuss them in detail because these are the mostly utilized standards for the standard data communication in the power system network. We will discuss them in detail. Other solutions are like web services, which are utilized for sharing the data among various enterprise applications. Multi-speak is another protocol for distribution system data exchange. Then various message buses, which are required for seamless integration of the data between various applications. One of such is the enterprise service bus, which ensures the standard way of data sharing between various software applications. Now, after the enterprise level, you will have the external world, where the information is shared with the external world for the other activities, or maybe sharing the information with the various stakeholders. So here the NIST domain which we can map is the market and the service provider. The example applications are like retail application, the aggregator operations, the regulator operations, maybe customers or the various service provider operations. So these are mainly the software driven applications where we will use the software related protocols. The most common is the internet protocol, which we commonly use to access the World Wide Web. Then enterprise business XML, that is EBXML, for sharing the business related data. And then IEC 870-6, that is ICCP, Inter Control Center Communication Protocol. This we will discuss when we will discuss the various SCADA protocol, what does it mean and why we use it. So basically, if you see the complete communication architecture, you will come to know that at various layers we use various technologies depending upon the area where the information is being collected. So the information is collected or generated at house area level, then it travels to neighborhood area network, then wide area, then enterprise. So all those 4 components are part of the enterprise level activities. That means these are part of particular utility. So after this, the information is shared in the external world for any information processing by the various stakeholders. So we will discuss couple of important technologies when we progress in this course.